Hey everyone. In today's video, I want to introduce you to the concept of module federation for UI applications. So module federation is a technique that allows developers to share code and resources across multiple independent applications at runtime. It's going to allow us to break up our big, large UI monolithic applications from one big monolith into multiple separate, independently deployable applications. In my mind, it's a very similar concept of what microservices is for the backend. Well, you can think of module federation of the equivalent for the UI. Essentially, we're taking one big monolithic UI, whether that's written in React or Angular, and we're breaking it up into multiple applications that are all going to tie together into one coherent app at runtime. So you can see I have this image here, which I think is a really good representation of what module federation is allowing us to do. Essentially, what we're going to do is we're going to build a single host application. So this here is the host application, and it is composed of three separate applications that are called remotes. So these applications here are remote applications. They're completely independently buildable and deployable from the host. So you could run app 1, app 2, app 3 totally independently on your machine. You can also build and deploy it completely independently. And then at runtime, what we're going to do is we're actually going to bring in all three of these remotes into the host here. And from the user's perspective, it's going to look like one coherent application. But in actuality, we're going to have many different applications here that are independently buildable and deployable. Now, another important thing to know is you can see here we've actually surrounded each application as a separate team, and that's one of the big advantages of using module federation, especially in enterprise contexts. As your application grows in size, you very likely might have separate teams that are responsible for different parts of that application, and module federation is key because it allows you to actually independently, as separate teams, develop, build, and deploy these applications separately on their own release cadence without having to deploy a big monolithic UI at the same time as everyone else. In this case, each team can have full control over their release schedule, when and how they actually deploy these applications. And in the end, at runtime, we're going to bring in all of the applications here on the host. So I'm super excited to jump right in and build an example application using module federation and show you the power that it offers us to break up our big monolithic UIs into smaller microservice-like architectures. Let's go ahead and jump in and start developing next. Now, before we jump in, I want to let you know that the full version of this lecture is available exclusively for members of my developer membership website, which you can check out in the description below. In the full version of this lecture, we take this example a little bit further and actually deploy our micro-frontends to a Kubernetes cluster. And I show you how to actually dynamically configure the paths to our remotes using a Kubernetes volume mount. So we can deploy this to a production setting and configure where our applications are pointing to at deploy time. Additionally, if you become a member of my site, you get access to all of my best-selling Udemy courses, including the latest one about building a distributed job engine using Nest.js microservices. So again, if you'd like to check out the site, I'll leave a link to the description below so you can get access to all of these courses and get access to all of these exclusive full video developer lectures. All right, so we're going to be utilizing NX, which is a popular monorepo manager to implement module federation. NX comes with first-class support with module federation and can actually generate all the applications, both the host and the remotes that we want for us automatically, which is going to save us so much time and make the application very efficient with a great developer experience. So let's go ahead and get started. We'll go ahead and create a new NX workspace. To do this, we're going to use npx create NX workspace at latest, and then we provide the name of the workspace. In this case, I'll go ahead and call it NX module federation. You can call it whatever you'd like. And then we'll set the preset here equal to apps, which is the architecture of this monorepo. We're going to have multiple applications inside of the apps folder, and we'll have any shared code inside of the libraries folder. So this will allow us to include multiple apps inside of our repo, which is what we want. We want both the host application that we see here and all of the remotes inside of one repository. Now, of course, this isn't a strict requirement. You can absolutely keep your remotes inside of separate GitHub repositories, but keeping them together like this is going to be a much better developer experience, as we'll see in this lecture. So let's go ahead and get NX Workspace set up. So we can go ahead and skip the CI provider as well as remote caching, since we don't need these at the moment, and go ahead and wait until your NX Workspace has been set up. All right, so now you can see that our workspace was successfully generated. I'll go ahead and cd into NX Module Federation. And so let's go ahead and get started by initializing our project. In this lecture, we're going to use Angular Module Federation, where we're going to have this Angular host and all of our Angular remotes pulled in here. Now, NX also does support React, so if you prefer to use React as the host and remotes, I will leave a link in the description below where you can follow along in the NX documentation, which we're following in this lecture. And the NX documentation has resources for both Angular and React. In our case, we're going to use Angular since it does offer, in my opinion, better support for module federation, including shared routing between our applications. So what we're going to do with our Angular architecture is actually have this Angular host here. And then what we can do is actually import the routes from each of these separate Angular remote apps and bring those routes together in the host. So each of them will have their own router and can define all of the routes and components that we want the host to be able to navigate to. So let's go ahead and add support for Angular by running nx add at nx/Angular. This will go ahead and get Angular set up in our project. So now we have Angular available. We're going to go ahead and use another nx command to now initialize module federation inside of our project. And it'll also create 3 new Angular apps for us. It'll first create the host application and then the 2 remotes that we'll go ahead and introduce. So in order to initialize this, we'll go ahead and run npx nx generate at nx/Angular :host. And then we define the path to the host folder. In this case, I'll call it store, so we want to generate it inside of app/store. And then we can define the remotes, which are the remote applications that we want to also create. So recall, these remotes are still going to be separate Angular apps that we're pulling in, and they're going to live in the same repo. So I'll go ahead and define products and checkout remotes, which again are separate Angular apps that are going to get pulled into this app store host. So let's go ahead and run this command. I'll just use regular CSS, Jest, and Playwright for the options. So go ahead and let NX initialize these applications inside of our monorepo. All right, so now that we've initialized our project, I'm going to go ahead and open it up in VS Code so we can dive into all the generated code that NX has created for us so that we can understand what's actually happening underneath the hood and actually be able to start building and serving this new module federation application. Now, at the root of the repository here, we can see all of the monorepo files that NX creates for us and that are shared between all applications inside of the monorepo. So this is going to include things like the Jest configuration, our ESLint configuration, prettier configuration, and finally, most importantly, this root NX JSON, which goes ahead and defines target defaults, which essentially are the tasks that are supported in this monorepo. You can see here we have targets set up to actually run Angular using build Angular. We have targets to enable linting, running our tests, and we have one for actually executing Webpack. So Webpack is the bundler that we're using, which is actually supporting the module federation. There's a module federation plugin actually built into Webpack that is going to actually take care of pulling in our remote applications into the host at runtime. So here we're simply opting into this Webpack target that we have available on NX Angular. So this NX JSON we can leave as is. It defines all the tasks we have available inside of the repo that the applications will inherit. So then we can see we have this new apps folder, and inside of here we have all of the applications that were generated for us by the NX command previously. So let's go ahead and start off by exploring the store application. This is the Angular app we just generated, which is actually the host of the module federation application. So let's go ahead and jump into this. The first thing I want to point out is this project JSON. So in NX, each application has its own project JSON where we define the actual targets. So recall we had the target defaults in the root. These are default settings applied to given targets inside of each project's JSON. So here, again, we have this Webpack browser target where we define target defaults for already, and we're defining more details to it. So as a normal Angular project, this looks a lot similar to an Angular JSON configuration. In NX, we simply supply all the options to the Webpack bundler here inside of the project JSON. So this includes properties like where to look for the entry point to the app, the root index HTML, and which TS config we're using. So all of these options are going to be key for running our Angular application. One important property that I want to point out to you is this custom Webpack config property. So recall we're using Webpack to actually hook together our module federation, and here we're telling the Angular compiler where to look for our custom Webpack configuration, which is where we actually define our module federation settings. So we'll go ahead and dive into this Webpack config here in the store folder next. Moving on to the rest of the file here, we simply have different configuration settings for different profiles. So a development build versus production, we're overriding some settings. And then we have the serve target. So this is what we're going to use to actually serve our code in development. And we're utilizing a custom NX Angular module federation dev server. Now later on, we're going to dive into more detail as to what this dev server is doing for us. However, I just want to point out that you can see any custom options we're supplying to it, including the port that the application will run on, the host, and more. So now you can see all these default targets that we have for this host application, which again is very similar to an Angular JSON, except now we're defining some extra properties to support our module federation. And again, this is done through the Webpack configuration. So let's go ahead and look at that next. Inside of store, we have the actual Webpack config that we are supplying to Webpack at runtime. So let's dive into a bit more as to what this Webpack configuration is doing here. So in this Webpack config, you can see here that we're actually exporting this function directly from NX module federation Angular. And this with module federation function is actually returning us a pre-configured Webpack configuration that is already hooked up and ready to work with module federation. So it's totally abstracting away all of the details required to work directly with Webpack and module federation, and all we have to supply to this function is a module federation config. And you can see here that's exactly what we're doing. We're supplying this configuration object config for module federation config. So let's go ahead and open up this file and take a closer look in here and see what we're actually passing in. So you can see here we have this config object of type module federation config. Each module federation config is going to have similar set of properties, the first of which is the name. So the name here is a property we'll find on both the host and remotes, and it simply is going to identify this given application inside of the context of module federation. So what is the name of it? Well, in this case, we call this host store. We just give it a string value. That's easy enough. Next up, we have this remotes property. Now this remotes property is the key bit that actually tells Webpack where to look for our given remote applications. Because remember, this host application is going to be running at runtime. It's not going to have built any of the remote applications. Instead, it's going to rely on this remotes array to read in, find out where the remote applications are located, and actually make a network request to them to download the respective JavaScript. And that's exactly what we supply here in this remotes array. Now, of course, you can see here all we're supplying is names of applications, seemingly here products and checkout. And this is another great advantage of using NX module federation is simply by providing the names of the applications here as strings. NX is smart enough to realize that these actually belong to other applications inside of our monorepo here. So when we run this host locally, it's going to know to actually look for these applications inside of our monorepo and serve the remotes directly from there. Now you can see here in this comment how we'd actually configure the remote to look at an external source, for example, when we're not running locally in a development server. So in this case, we have some external remote defined and then the address to that remote. However, for now, for local development, this method of simply providing the name of our application that is a remote inside of our NX monorepo is going to work great. So as I said before, we're going to dive deeper into the NX development server later on, and I'll explain to you actually what's happening here to these remotes that we're providing when we run our application in development. But just know that this is the configuration object that we're supplying to Webpack, and it's actually going to tell it where to look for our applications at runtime thanks to this remotes array. Now, importantly, you can see we also have a webpack.prod.config here, which is simply another Webpack file used for the production build. You can see we're still importing the module federation config, and we have another example here where we can define our remotes from an external URL. Now, later on in this lecture, I'm going to show you how to actually load our remotes in dynamically from a JSON file, so we can actually swap these remotes out at runtime, and we don't have to rely on hard coding them in here statically for build time. Instead, we can do this all dynamically through a JSON configuration file, which we'll see later on. So let's go ahead and keep on digging into this store host application by going into the actual source code for this Angular app now. So we'll start off here at the main TS. So nothing looks different here from a normal Angular application. We're simply importing the Bootstrap file and starting our application up. And again, here you can see there's really no difference here in the Bootstrap file. We're bootstrapping our application by passing in our root app component and then passing in the application configuration object. And finally, the root index HTML file, we're simply displaying the app root. So nothing really different from a normal Angular application here yet. Let's start off and look at the root app config. Again, there's zero difference here from a normal Angular app. We're providing our zone change detection as a provider, and then we're providing our app router here, our root app router. And so that's where we're going to see our first difference in this Angular app. So let's hold off on that for a second and also just take a look at the root app component. So in the root app component here, you can see all we're doing in this standalone component is importing this welcome component and the router module. So that's going to set up routing for our application. However, now I want to take a closer look at the app routes that we're defining for our host application. So open up the app routes file, and in here we can now finally start to see some of this module federation magic. So here we're actually defining the application routes that exist on the host application. You can see the first route here, the homepage route at the root of the app. We're simply displaying our NX welcome component. However, at these paths here at /checkout and /products, you'll notice we're now using the load children function. So load children in Angular is simply going to lazy load child routes that we provide. Now, to actually get access to these child routes, you can see we're performing a dynamic import here. So we're importing checkout/routes, and then from there, we're actually just providing the routes object from this remote application. Well, we know, of course, this import here, checkout/routes, actually corresponds to one of our remote module federation applications. Now, importantly, the reason why we're able to do this import at checkout/whatever is because, recall back in our module configuration here, we actually provided the name of these remotes here in this array. So because we have this checkout string here, we're able to use the import here, checkout. And at runtime, NX module federation will see that we're importing from checkout. It'll recognize that this is a remote defined here in this array, and it will automatically know to load in the remote application from inside of our monorepo that should be running on a different development port. So this is actually going to reach out to the remote at runtime through a network request, and then it's going to target this /routes import, which we'll see in a second when we look at the checkout application and see that we're actually defining this routes export to make it available to the host application. So in the end, what this is going to do is it's going to actually provide the routes from each of these remote applications and provide them here to the host application so that when we go to /checkout, we're going to load this remote application and make these remote routes available on the host. So now let's take a closer look at one of these remotes and understand how this import is actually working a bit closer. So next up, we'll open up apps/checkout and take a closer look at this remote module. So let's take a closer look at one of our remotes that we're feeding into our store host. So we'll go ahead and open up our products remote first and take a closer look at it. So let's start off by looking at the root webpack config for this project. Now, of course, we also have a project JSON because this is a independent Angular application. We can serve, build, and deploy just this product's application alone, and that's a key benefit to this micro front-end architecture. So you can see here for our build target, we're still using this Angular Webpack browser with its own root index HTML and its own main entry point. We also define a TS config for it, assets, styles, anything you'd find in a normal independent Angular application we have here. So you can see we also have our NX Angular dev server that is going to be able to serve our application now on port 4201. And now let's dig into the root webpack config here. So this doesn't look any different from the host webpack config we already saw. We're utilizing the common with module federation function from NX that's going to take care of all the configuration settings we need to actually expose this remote to the host. And so now if we look at the module federation config for this remote, we'll see it looks a little bit different from the host. Firstly, we have a separate name for it where we're setting it to a product string since it's a separate application. And then we're defining this exposes object. So in module federation, we actually have to explicitly define any code that we're exporting from the remote and making available to the host. And we do that here in the module federation config through the exposes object. So in this case, you can see we're actually exposing this component /routes. Now remember, if we actually go back to our host app router where we're actually utilizing this remote, take a minute and look at the import that we're actually using to load the remote. So remember, we're importing products/routes. Well, this syntax corresponds to the following module federation config. We assign the name of products here, which is the name we have here in the remote module federation config. So that's going to find the correct remote. And then we use / to access the corresponding exposes module from the exposes object. So in here we have /routes because we defined /routes here in the exposes object. And now the remote is going to define where in our code we are actually exporting this module from. In this case, you can see here we're using this remote entry.routes file. So if we take a look inside of source, app, remote entry, and entry.routes, we can actually see the remote routes we're exposing to the host. And in this case, it's simply a set of routes. So here at the root path, we're exposing this remote entry component. And this entry component is a simple component that is just exporting our NX welcome component here, which is a pre-built starter component. So essentially what this means is when we navigate to this remote, we're going to render this component, remote entry component, thanks to the exposes property here. We're exporting this whole router. So we can continue and add on additional routes to this router that will be made available to the host at runtime. So everything else inside of this remote application would look just as we'd expect. So we have a main TS importing our bootstrap. This is calling bootstrap application with our remote entry component, which again is this same remote entry component we expose to the host through our entry routes. And the app config here is the standard app config we'd expect. So hopefully you see how easy it is to expose code to a host using Webpack module federation. All we have to do is include the code, in this case the routes we're exposing to our Angular host through this exposes object. Now we'll find the same exact structure inside of the checkout remote. So now let's go ahead and take a look and see how we actually can build and run our application. So in order to go ahead and build our application and actually be able to run it, we're going to use NX serve, which we know is going to execute the serve target we define inside of the store project JSON. Well, if we scroll down, recall we're using the serve target here. So this is where we define it. And we're actually using this pre-built Angular module federation dev server to execute the server. So we're going to execute serve against store, and we'll go ahead and see what happens here. So we're executing this serve development command, and you can immediately see that NX detects that we're actually trying to run store with 2 remotes. Now, the reason why we see this is because we have actually explicitly defined these remotes inside of our module config here inside of this array. Now, since we're defining this as simple strings here with no additional address, like in this example with a tuple, NX knows to look inside of the monorepo to find these remotes, and that's exactly what it's doing. It's found these remotes inside of our repo, and it's building the remotes and getting ready to actually serve the remotes through a static server, because by default, we're simply going to build and serve our remotes and not enable a dev server against them. Now, finally, you can also see that the compilation was successful and our Angular dev server is now up and running. So we can go ahead and open it up on our browser at localhost 4200. So now you can see I've navigated to the browser here, localhost 4200. Now you can see here we have our hello welcome store component, which if we go back to our host code and take a look at the entry point for Bootstrap, recall we're rendering the app component directly. And this app component is simply importing the NX welcome component from host. So that's the component here, NX welcome for store, this starter template that we're actually rendering here on the home screen. And this is because our app routes have defined the route path here to render the NX welcome component. Now you can see here, let's go ahead and try actually navigating to one of our remotes by going to the /products route. Now we can do this already thanks to NX including our remotes here inside of this menu structure. So if we click on /products, we're actually brought to the remote application here, our products remote, which is a completely independent Angular application. And to make this point even more clear, I want to go ahead and open up another development server against our project. So in another terminal, let's go ahead and cd into the same project directory. And now what I want to do is rerun the nxserve command, but now execute it against one of our remote applications to show you that it is an independent Angular app. We can serve the products application here all on its own without any host. So now you can see here the Angular dev server has actually built and served our application. And now if we navigate to localhost 4201, well, we're actually just looking at the remote application itself, not inside of the host. And this shows us that this really is an independent Angular app that we're serving, can build and deploy all on its own. And so this is the same remote that we're actually injecting into the host here at runtime when we navigate to /products. So we can actually even see this if we look in the network tools as well. When we go to our application and refresh, you can see that we actually load up these 2 remote entry files from localhost 4201 and 4202. So the remote entry file is the actual compiled JavaScript from the remote that is fetched from the host at runtime and includes all of the exposed components that we defined in our exposed object on that remote. We can even navigate to this remote entry.mjs file at localhost 4201, and you can see the actual raw JavaScript here that we're exposing to any hosts that want to consume it. And this is really the magic of module federation. It's being able to download these remote entry files at runtime and actually use that JavaScript when the user navigates between these completely independent Angular applications. So hopefully you can see the power of module federation in this case, where we have this host that's running completely independently of any of these remotes. What this means is because we're actually fetching the remote at runtime when the user navigates to the host, what this means is we can actually update this remote here that's running. We can update this remote independently, and as soon as we update it, well, whenever we navigate to it from the host here at runtime, we're always going to be fetching the latest version. So what that means is we can make changes to this remote, push those changes, and have them reflected on the host. And this is going to be completely independent for each of these remotes. They can each have their own independent development lifecycle, which is one of the major benefits of using module federation, as well as quicker build times, right? Because we're building a singular Angular application in the case of each of these remotes instead of one monolithic application. So one more thing I want to show you in terms of the NX dev server is we can actually serve the host applications, so serve store. And then we can also tell NX to listen for changes in our remotes in the same terminal session here by supplying this dev remotes argument. So we can say we want to launch the products remote and the checkout remote in development mode. And we can see here what that actually is going to do is start 3 different development servers, one for our host and one for each remote. So now when we make changes to either the host application or the remote here, our application is automatically going to update in real time, which gives us a really great developer experience and a good reason to use NX for module federation. All right, so now you've seen module federation in action and hopefully seen some of the benefits of being able to compose this application here at runtime by pulling in these completely independent remotes by fetching that remote entry.js. Next up, what I want to show you is how we can actually make this module federation completely dynamic. Because right now, in our current setup, we are actually defining the remotes that we're pulling in at build time because we have this static remotes array. Instead, what I want to do is define a dynamic JSON file that's going to supply all of the remotes and where we can fetch them from. And then we can read this JSON file in at runtime to know which remotes we have to download and make available. And the big benefit of this is we can actually update this JSON configuration file after we've built the application and achieve the ability to update where our remotes are at runtime. And this is a major bit of flexibility because we can now actually change where we want to point the remotes at runtime without having to rebuild the code. All right, so let's go ahead and update our application to achieve this dynamic module federation so that we can actually update where our remotes are located at runtime and not have any static build time dependencies on the location of our remotes and achieve true dynamic module federation and achieve ultimate flexibility. So the first step is to go back into our store host application, and in the public folder, we're going to go ahead and define the static JSON configuration file where our remotes are actually located. So we'll go ahead and call this module federation.manifest.json. And in here, we're going to define the location of our remotes. So to do this, I'll provide a key value pair of the remotes and their address. So the first one will be our products remote. And we know that this is listening on localhost 4201. And then we're going to point it at a file that our remote applications are actually already making available through Module Federation Webpack and Xangular. And this is called the mf/manifest.json. So we can actually see what this looks like by navigating to our remote application. Make sure we have the products application actually running on 4201. And if you navigate to /mf-manifest.json, you'll actually see here a manifest file that NX Module Federation has automatically generated for us. And this is going to provide the host application with metadata that it needs to actually pull in the remote at runtime. So you include information here like the remote entry name, shared dependencies that we're actually sharing between the host and remote at runtime, and more. So this is a key file that we need to supply to the host, and that's what we're defining here is the path to it, which we'll be making available automatically in any of the remotes that we run both locally and in production. Finally, we'll also add the checkout remote here. So this will be the similar but on port 4202. We'll access manifest.json. And so here, I want you to show you really the power of having this JSON file, because next up what we're going to do is change our code to actually fetch this at runtime when the user navigates to the host. And the real power of this is that we can actually update these addresses at runtime to point to a separate deployed remote. So you can imagine if we have several environments where we're deploying our code to, perhaps we roll out a change with some updated code. And so we have a remote here defined at our production URL. And then say we have a fallback environment where we have the older version in case anything goes wrong. Well, if after upgrading to a new remote by updating this URL here, if we need to fall back and revert that change, we can simply change the remote address here at runtime to point to our older remote. So it really gives us the flexibility of composing our applications at runtime by controlling this manifest JSON file. So now that we have this manifest file, let's go ahead and update our code to actually read it in. To do this, we're going to go back to the store main TS, and we're going to go ahead and update this file. So the first thing that we're going to do is a fetch call to fetch our module federation.manifest.json. Now, since we've put it here in the public folder, NX automatically makes all of these files in here available as assets at the root of our app. So we can simply fetch them here using the fetch API. So we're fetching this federation manifest at runtime, and then we'll call then here to pull off the response from the fetch request and convert it into JSON with res.json. And then in the next then, well, now we have access to the actual remotes as a JSON object. And so this is going to be of type record string. And in here, we're now going to return a call to object.entries. Now, object.entries, what we want to do is simply map over all of these key value pairs and build an object with them that NX module federation actually expects. So we'll go ahead and pass in remotes to object entries and map over the key value pairs. So to do this, we can destructure the name and the key returned from object.entries. And now we want to return a new object that contains two properties, the name of the remote, and in this case, well, let's change this to entry. This will be the URL to the remote entry. And so the reason why we need to do this is because I then want to call .then, where we now have access to the given remotes, and call the init function. And we're going to go ahead and import init from at module federation /enhanced /runtime. So this init function is a special function that actually takes in a module federation manifest in this form where we have the name of the remote and the address to it. And so that's what we've done. We've taken this JSON file and built this object out of it. Now we can supply it to init, and init is going to take care of actually reaching out to the remotes and injecting them into our host application dynamically at runtime, so pass remotes into it. So in order to do this, we simply call init and pass in an object. So we have a name property, which is the name of the host. In this case, we'll call it employee. And then we have the remotes property, which again is this object of key value pairs to the remotes, and we can simply pass it in. Finally, we're going to call .then again, and now import Bootstrap to bootstrap our Angular application, and we'll call catch and log out any errors that occurred during this process. So now we've successfully fetched the federation manifest dynamically at runtime, fed it into this module federation init function, and that means we have these remotes now available dynamically at runtime. We can also now go back into our module federation config and remove the statically defined remotes here in this array, since now we're actually defining them through this module federation manifest. Now in production, when we deploy our application, we're going to swap out these remote URLs to where we've actually deployed the remotes to in production. And this is going to be very easy to do because all we have to do is change this JSON file after the application is built, and we can simply fetch it with our new updated main TS file. That's going to ensure we load in all of these remotes listening on their production URLs at runtime. One last change we need to make is to go back into our app.routes for the host and change how we're actually importing the remotes. Now we're doing it dynamically. So inside of load children, we now want to go ahead and use the load remote function from, again, module federation enhance runtime. So since we called init earlier, this same function will actually know how to load in the dynamic remote we provided thanks to the init function we called earlier. We simply have to pass in the path to the actual module, and this is going to be the same path we used earlier, so that's going to be products, the name of the remote, slash routes, which is the property we set in the exposes object for the remote. Then we call .then, where we have access to the module, and return the module.remote routes property. Now we also need to define a static type here in load remote, and so I'll just supply type of import and provide the same import, and this is going to give us type inference directly to the load remote and make this operation type safe, where we actually have access to the exports through the exposes object, which is a really great feature and another super great reason to use NX for this, because we have this end-to-end type safety even when using dynamic module federation like in this example. Now of course, since this is checkout, let's go ahead and change the string to checkout instead, and then we'll go ahead and copy and paste the same configuration below for products and change the route to products instead. So now at this point, we should have everything in place we need to test out our new dynamic module federation. I'll go ahead and restart our development server. So nx serve store. We can also keep our dev remotes here. So again, we still have this hot module reloading between all of our applications. You can see our compilation was successful, and we can go back to our host homepage. We're still able to navigate to products and checkout, even though we're actually injecting the remote module federation configuration dynamically at runtime. And we can see this in the network tab here. When we refresh, we're fetching this module federation manifest, finding out the path to these remotes, and then using this to actually reach out to them and fetch the manifest. So you can see that here in the below requests, we're fetching the MF manifest. And then finally, the same procedure that we saw before, downloading the remote entry from each one. So now we have this fully dynamic module federation, and we can actually change the path to these remotes at runtime. So I hope you learned so much about module federation today and the advantages that it can offer when building large monolithic UIs. It allows us to separate out our applications into independently buildable and deployable applications, and this is really important when we want to have independent release cycles for each of these apps. We can update any of these remotes here without affecting one another or the host itself, and to the user, we have a seamless, coherent experience navigating between all of these apps. Now, if you'd like to get access to the full version of this lecture where we take our application a little bit further and actually deploy it to a real Kubernetes cluster, you can head over to my developer membership website, which I'll leave a link to below, and get full access to the entire lecture where we deploy this to a Kubernetes cluster and configure our remotes dynamically at deploy time. So thank you so much for watching, and I'll see you in the next one.